Okay, so in this section, we are going to discuss about increasing, decreasing, piecewise functions, and some more function as well. And then always there is an application. That's the reason we talk about different type of function. So first of all, we're going to see, in the graph, what does it mean? Increasing means, or decreasing means, or constant means, or piecewise means. uh, and then yeah, that's the objective for this section. Increasing means whenever you go and plot the graph, and if you go from left to right, if the graph is going up, that's the increasing function. If the graph is going down, that's a decreasing function. So let me show you one example here. Remember, we plot the graph in the coordinate system. So when we plot the graph in the coordinate system, let's say this is the graph of the function. So as you can see, when we go from left to right, the graph is going up. That's why it's up to this point, and then after that it's going a little bit down, and then again up. So up to this point, let's say x equal a, from left side to the a, the graph is increasing, and it's slightly decreasing from a to b, because from here to here it's going down, and then again after b it's increasing. So how do you know? By looking the graph, it's easy, but sometimes they give you the function, and then you need to compare the value of the function at different points. So let's say this is the graph. This graph is increasing because the value of the function at right point is greater than the value of the function at left points. So our function f is said to be increasing on an open interval, any open interval. In this case it's a to b. If for all a and b in the interval, the value of the function at b is greater than the value of the function at a. So that's a proper definition. And then similarly, decreasing means the opposite case. The value at b is less than the value at a. And constant means the value doesn't change. The value of the function is always constant. So it's a horizontal line. So let's look at some example from the homework problems. Look at this graph and tell me where this function is increasing and decreasing or constant. As you can see here, from left to right, when you move from left to right, starting at -5, the graph goes up to 2. So from -5 to 2 on x-axis, the graph on the y-axis is going up. So that's where it increases. So from -5 to +2, the graph is increasing. On that interval, the graph is increasing. For the increasing or decreasing or constant, you don't have to make it close bracket. Open parenthesis is fine. The function is decreasing. As you can see, if you make it bigger, from 2 to 4, the function is constant. From 4 up to 6, the graph is going down. So from 4 to 6, it's decreasing, right? And then from 2 to 4, it's constant. 2 to 4, it's a constant graph. Okay. Okay, so that's the increasing, decreasing, and constant. So there is one very useful property we can use from the graph, that's called relative maximum and minimum. It's a little bit different than the minimum and maximum value. To understand the concept, let's look at this graph here. This point, this value is called relative minimum, and this value is called relative maximum. You should make sure that, look at here, this is not the largest one, or this is not the smallest one, but still it's a relative maximum or relative minimum. It's called relative maximum if that value is greater than its neighboring value. If it's greater than left side value and then right side value on some open interval, that's the relative maximum. If it's less than, if its left value or the right value, that's the relative minimum. So the value of the function at any point c is the relative maximum if there exists an open interval where c, the value of the function at c, is greater than all the value on that interval. Similarly, the very same value is relative minimum if the value of the function is less than all the value on that small open interval. We can use this relative maximum or minimum idea to solve application problem. Let me see if I can find. Okay, so this is the graph here. It's a parabolic graph, quadratic function. We need to find out where this function has a relative maximum or minimum. As you can see, the graph is going up, and this point, after this point, the graph goes down. So this is the maximum, relative maximum, or the largest one for this graph, and there is no minimum because this graph is keep going down. So this is a very, very special type of the graph. It's a graph of quadratic function, and the answer is relative maximum value occurs at negative 2.5, and the value itself is 3.25. The value occurs at x coordinate, and value itself is the y coordinate. So the answer is the relative maximum value occurs at the value is 3.25, that's the y coordinate, and that occurs at x coordinate, which is negative 2.5. Okay, and if you look at the minimum value, there is no minimum value because the graph is keep going down, and then there is no relative minimum value in this graph. The function is increasing, as you can see if you look at the graph. To the left side of this maximum value, the function is increasing, and to the right side, the function is decreasing. So from negative infinity up to negative 2.5, the function is increasing. From negative infinity up to negative 2.5, that's the x coordinate, the function is increasing, and from negative 2.5 to positive infinity, the graph is decreasing. Okay, there are very special type of function we're going to discuss now. The one of them is piecewise function. Piecewise function means a function which is combination of more than one function, and we can form them by using into different pieces. For example, in this example, you can see here the value of the function is x plus 1 on this interval, the value of the function is 5 on this interval, and the value of the function is quadratic on this interval. So when we try to plot the graph, in the Cartesian coordinate system, for the x is less than negative 2, so let's say this is negative 2, and this is 1, 2, 3. The graph to the left side of negative 2 has to be this line. The graph has to be y equal x plus 1. Y means the function. From negative 2 to positive 3, the graph would be y equal 5. So from negative 2 to 3, it's easy. So y equal 5 means from here to here, it's like a straight line. Okay, so from greater than 3, it's a quadratic. So from greater than 3, it's a quadratic. So when x is 3, it's a something look like this. When x is negative 2, it's a negative 1. So somewhere here, the graph would look like this. So this is the three pieces: the straight line on the left side, straight line in the middle side, and then parabola on the right side. So you can plot this graph by finding different points. I already knew the nature of the graph, that's why I did it like this, but you can plot them separately. But as a whole, this type of function is called piecewise function. There is one more function I'm going to introduce here. This is called the greatest integer less than or equal to x. If you find this symbol, this means anything comes inside there, the value of the function is the integer less or equal to that value. For example, if there is a -5, the value of the function is supposed to be -5 because -5 itself is the integer. If there is a -5.2, then the value of the function is supposed to be -5 because the integer less than -5.2 is -5. So this is how you calculate the function. Let's look at more example from your homework here. It's a relative maximum minimum. That's easy. Okay, the problem like this, what is that? Piecewise function. We just discussed about the piecewise function. Here, this is the piecewise function we have given, and then we are asked to find, let me just add some blank pages. Okay, we're asked to find the value of the function at different point. As you can see, we are asked to find the value of the function at -8. So you go here and check where that -8 fits. Anything x less than or equal to 1 can be calculated by using this formula. So we're going to use the first part, which is x plus 2, to calculate the value of the function at -8 because -8 is less than 1. So you just replace x by -8 and that will give you -6. So the value of the function at this point is -6. What's the value of the function at 1? One more time. For x equal to 1, the very same function we're going to use. So x1 plus 2 is 3. So that's the value of the function. Anything greater than 1 goes here. So 9 minus x. So you have to use the formula 9 minus x to compute for anything greater than 1. So 9 minus x. If you want to find out the value of the function at 2, this is the formula you have to use, and in this case that's 7. Okay, that's how we can find out piecewise function, and based on the values we can plot the graph of the piecewise function. Okay, that's all for this section.